Hello, how's it going? In this video, I'm going to set up my program so that instead of having a bunch of textures that I bind individually, I'll have a single texture array with the individual textures in the appropriate slots. And that sets it up so that, yeah, the program looks the same. However, it doesn't need to be continually binding and rebinding textures. This video will seem pretty similar to the vertex lumping video, and that's because there's a common theme. It is generally better, rather than having a whole bunch of little resources, it's generally better with graphics programming to find a way to collect those resources together and send in one big resource so that, well, it doesn't matter that the program doesn't it doesn't matter that the program has more than it needs at a given time. It's best to have all the data up front for every type of resource. So if you head into the repo for this, you'll find that there is a slight difference in the resources. Just go to the textures folder. We've got these. Actually, let me just check that I've added these properly. These haven't come through. Okay, I'll just quickly delete all of these. Anyway, so where was I? The point I was getting at is I've modified these texture files. So if I pop in here, now they are all PNGs. They're all PNGs, and they've all been changed to the same size, 1024 by 1024. That is one restriction we need to deal with image arrays, is all the arrays need to be the same dimension. So what we'll do is just grab all of these images and drag them in to the textures folder, and this will just... Oh, why did you just copy one? I love this. I love this. Okay, let's try that again. 4 items? Yes, 4 items. There we go. And mouse has been added twice, no worries. Okay, good. Excellent. All right, so back to it. So I'll just close this down, and what I'll do is in the view folder, I'll make a new file, a Swift file, and I will call that material lump. So that's what it is. It takes in a whole bunch of materials and lumps them together. So I'll just import metal kit, and I'll define my class. And I'll just give an overview of the functions that I'm going to have for this class. So first of all, I'll have an initializer. And what the initializer will do is create a texture and a sampler, pretty much. But it will also set things up. It'll set up a command buffer and blit command encoder. And those are used so that later on, when I consume another texture, I'll record a command with the blit command encoder, which will copy from the texture to our texture, if that makes sense. But then the thing with command buffers and commit blit command encoders is they need to be finalized. So we'll also make a finalize function. Okay, so why not? I'll actually go backwards. Actually, no, that's a bad idea. Let's go from the start. So I'll just declare the variables that I'll have. I will have By the way, big credit to Mick Zonk from the channel Discord for pointing me back onto this blit command encoder. When I was researching this video, I was looking for ways to copy from textures to textures and just for some reason passed over it. But thank you, Mixonk. It really helps. I really appreciate it. So let's go in and initialize everything. Now I'm going to need a few things. I'm going to need a device. And going to need to know how many layer counts or how many layers I want to initialize my texture with. Now in order to create the command buffer and so on, I'll need a command queue. And in order to make sure that when I copy the textures over, they have the correct pixel format, I'm also going to take in the format of any one of the materials. I make the assumption that they all have the same format. Okay, now this next bit is not going to be a lot of fun. There's just going to be a lot of writing. So I'll just fill this in. I need to create a texture descriptor. Okay, so just a note here, we have sort of a unified system. So when we create a texture, even though we're creating a 2D texture or a whole bunch of 2D textures, we do need to specify that they have a depth of 1. If you just imagine a thin layer of paint, it's depth 1, that's a 2D texture. Where we specify the number of slices for our array is here in this array length argument. Now, when I was reading the documentation, some of these, not all of these seem necessary, but why not include them? So I'll just include this argument if it helps at all. Okay. Allow GPU optimized contents, let's say true, and there we go. Okay, cool. So we can now create the texture. So there are sort of two main ways to make textures. What we've been doing so far is using the texture loader to load directly from a file. But another way to do this is simply to populate one of these texture descriptors and then call the device's texture create function. And that will create a blank texture with the memory allocated, but nothing in it. So then I'll just go command buffer. So the idea with command buffers is that they do work. And what we've been doing so far in the renderer class is when we went to draw things, we had a command buffer, and then from there we made a render command encoder. That's for encoding rendering commands. And another type of work we can do is blit commands. Now a blit is to copy a chunk of memory from one location to another. So probably the easiest way to deal with memory copies is with a blit command encoder. Okay, so we also need to make a sampler, but if we go to the material, we can pretty much use the same sampler. As a matter of fact, now that I think about it, material probably doesn't need a sampler because we're not sampling from it. We're just using it as a temporary placeholder and then copying over. So we can simplify that code a little bit too. Okay, yeah, very nice, very simple. All the material class does is takes a file name, loads it into a texture, which we then use. Okay, so now we've created everything. We've set things up. The command buffer is ready to encode, to record commands. The blit encoder is ready to encode commands and so on. Everything's good to go. So let's go ahead and consume a texture. So I'll just call this argument material, and that will be a metal texture. And then we also need to know what layer of the array we're going to copy this to. But otherwise it's pretty simple. So we just take our blit command encoder and we tell it to copy. It's probably this one here. Okay, so we'll copy from the material. Now, the material is a regular two-dimensional texture, so we'll always be copying slice 0. So the way slices work is if you imagine layers of textures in the image array, the slice is the index of the layer. So when I have my, this will make sense. So the source level, there's the mip-map level, that'll be 0. And then the texture that we're copying to. So we want to copy to our texture. And then the destination slice that we copy to is the layer where we want this to end up on the texture array. Destination level will be 0 as well. Now slice count and level count will both be 1 because we're just copying, we're just copying one image. Okay, so that is all well and good. Then finalize. So to finalize, we take our, what are you doing? Blit command encoder and tell it to end encoding. Okay, excellent. Then we take our command buffer and we commit it. And then probably a good idea for stability is take the command buffer and wait until completed. Now we don't need to do that in the draw function because the SwiftUI framework does a pretty good job of requesting animation frames at the correct time so that we're not working with an active command queue. Fingers crossed. So yeah, that's it. That's how it works. So let's go ahead and use that. So we'll go to the renderer, and one thing I'll do is up the top, I'll still keep these materials that I'm making, but I won't declare them as class variables. What I will declare is my material lump. Okay, so I'll just make these as function level variables. And I should probably change all these extensions because they're all PNGs now. Okay. Excellent. So now what I need to do is make the material lump and consume all of them. So I'll go sorry, that's already been declared. Material lump. There we go. So for the device, I'll use the metal device. Layer count, I can see right here, I'm going to have 4 layers. Command Q. There we go, got that there. And for the pixel format, like I said, just pick any of them and that's fine. So I'll take the first one, my arty material, take the texture, and then grab the pixel format from there. Okay, so now the material lump will consume each of the textures. So I'll go material lump, consume, we'll go just in order. So the arty material will be layer 0. And whoops, what am I missing? I want the texture from there. Okay, excellent. Now all we need to do is tell the material lump to finalize itself, and that should all be baked in. Now we are going to have some problems still because our program is set up to use multiple materials. So what I'll do, if we look here, we have this arm for drawing function, and that binds the material. But what I'm going to do is just bind the material once at the start. So where's this bit? Yeah, set fragment texture and sampler. If we just go up to draw lit objects, this is where we're sending in the vertex menagerie. So let's do the same thing. Let's go material lump texture and material lump sampler. Okay, so we bind them in once at the start of the frame, and then everything else uses them. That's fine. And now I'm just going to get rid of this arm for drawing function completely. And I'm also going to get rid of all of these calls. Okay, so imagine that we have our shader, and our shader has all of the materials that we're ever going to need to render our scene. How do we specify which material to use for which object? Now, there definitely are more sophisticated ways of doing this, which I'll look at in future. Same thing for the, where are we? If we go down to draw, yeah, same thing for the model transform. We should not be setting this per object, but since we're setting it per object, let's also set the material per object. Except it seems a little weird. Instead of binding a new material, we'll just send in a float to indicate which material index we're after. And then in future, when I fix up this issue, I'll fix up the material issue as well. Long story short, what we do is we send in all of the model transforms up front. We also send in all of the material indexes up front, and then the drawing goes just fine without even this per object stuff. But I'm getting a little bit ahead of myself, so I'll just pop over to the shaders and set them up so that they can use array textures. So over here we have the vertex shader, that's fine. It's this bit here, the fragment shader, that I'm really interested in. So I'll just go here and specify, okay, this will be an array texture. And I'm also going to take in a float called material index. And I'm going to take that in at buffer position 4. So a little wasteful using a whole buffer just for one float, but like I said, this is a temporary solution. We'll fix it up later. So now the sample function doesn't work. And the reason for that is we need to pass in the material index as another argument. And it's, oh, that works. Okay. Okay, yeah, excellent. I thought maybe we'd have to change that to an int, but turns out it's fine. Okay, so let's set up the unlit shader the same way. Now, this one is significantly simpler. We'll just go through the same motions. So we'll say, okay, that's an array texture, and then I'll add in the float. And I'll keep that at buffer 4, the reason being that I can then use the same binding function or the same set vertex bytes function for each thing. So where was I? Okay, excellent. So let's go back, and the key is this draw function, because this draw function is already taking an integer, which is being used for the vertex menagerie. So let's use that integer again. Just say yeah, so it is a little weird that I'm taking integers, casting them to floats, and then sort of using them like integers. But as I've said in the past, maybe it's just me, I have bad luck with using integers in shaders. It just hates them. So I'm just going to avoid that altogether and just deal with floats. There's a small overhead, it's not a big deal. So then I'll say, where am I? Render encoder set fragment bytes. Now the bytes will be that basically 4 bytes, but I'll look this up. And then the index will be 4, because that's buffer 4 in both shaders. Okay, so it doesn't look like we have any errors. So let me just briefly go back over what I did. Before I had 4 materials. The issue was that every time I drew a new object, I bound a new material, and there's some overhead in that. So to get over it, what I did is I created a texture array, and I loaded in each of these textures as different slices of the array. So then what that means is I can bind a whole chunk up front, and that reduces the overhead because I'm not constantly switching around. Now, like I said, it's not a perfect solution yet because, well, it's a work in progress. I'll get there. But what I'm doing at the moment to get around that is in the draw function, it has been specified the index of the thing that I'm drawing, and I'm just passing that through as a simple float, which I'm then using on the shader side to access the appropriate layer of that texture array. So fingers crossed, let's just see how this goes. Yeah, awesome. Awesome. There we have it. By the way, I got that walking code working. Okay. Cool. So like I said, not a super big deal right now, but later on as our scenes get bigger, this is the more mature way to be rendering things. Okay. So yeah, have fun, all the best, and I'll have a good weekend, and I'll see you again soon. Bye.